Good morning, dear students. Today we are going to see about lens, its definition, types of lens, rules, refraction in lenses. First, definition of lens. A lens is an optically transparent medium bounded by two spherical refracting surface or one plane and one spherical surface. Lenses are divided into two types: convex lens or biconvex lens, concave lens or biconcave lens. We will discuss the difference between convex and concave lens later. Next is other types of lenses. Convex lens is otherwise called as converging lens. Concave lens is otherwise called as diverging lens. Plano-convex and plano-concave lenses have one of the face has plane meniscus. Stepper convex surface is thick at the center, it is called positive meniscus. Stepper concave surface is thin at the center, it is called negative meniscus. Images formed due to refraction through a convex and a concave lens. When an object is placed in front of the lens, the light from the object falls on the lens and we can get the position, size, nature of the image formed. That can be understood easily when we know the basic rules. First rule is the center of the lens is called optic center O. When a ray of light passes through convex or concave lens obliquely at its optical center, it is continuous to follow its path without any deviation. Second rule is when a ray of light passes parallel to the principal axis and strikes a convex or concave lens, the refracted ray are converge convex and diverge in concave from the principal focus. Third rule, when a ray of light directed towards the principal focus after strikes a convex or concave lens, refracted ray will be parallel to the principal axis. Dear students, study these three rules thoroughly, then only we can know the refraction. First, refraction through a convex lens. Formation of images by convex lens when the object is placed at various positions. First, we are placing the object at infinity. In infinity, real image is formed at the principal focus. Object at infinity, image will be formed at F. Image is much smaller than that of the object. This is what we use to play with the lens. The sunlight is focused in a point-sized image. Next position is object is placed beyond C. Here real and inverted image is formed between the center of curvature and the principal focus, that is between C and F. So beyond C, object is placed, image will be formed between F and C. Next position is at C, object is placed at C, the image will be formed at C. Here real and inverted image is formed at the C. The size of the image formed is smaller than the object. The size of the image will be smaller than the object. Object is placed C, image is appeared on C. Next position is object is placed between F and C, that is principal focus F and the center of curvature C. Here real and inverted image is formed behind the center of curvature, that is size of the image is bigger than that of the object. Object is placed between F and C, image will be formed beyond C. Next position is object is placed at the principal focus F. Here real image is formed at infinity. The size of the image is much bigger than the object. Object at F, image at infinity. Last position, object is placed between principal focus F and optical center O. Here the image will be formed on the side of the object. This image will be a virtual image. Size of the image is larger than that of the object. This is what applied in simple microscope. Application of convex lens. It is used as a camera lens, magnifying lens. It is used to make microscope, telescope and sliding projectors. It is used to correct the defect of vision called hypermetropia. In concave lens. When an object is placed at infinity, a virtual image is formed at the focus, principal focus F. The size of the image is much smaller than that of the object. The position in concave lens. When an object is placed at a finite distance from the lens, a virtual image is formed between optical center O and focus of the lens F. Here also size of the image is smaller. In concave lens all the images are virtual. It concludes in concave lens, the distance between the object and the lens is decreased. The distance between the image and the lens also keeps decreasing. The size of the image formed increases as the distance between the object and the lens is decreased. Application of concave lens. Concave lenses are used as eye lens of Galilean telescope. It is used in wide angle spy hole indoors and it is used to correct the defect of vision called myopia. Dear students, that's all about today. Listen, understand and study well. Write all the definitions in your classwork note. Okay, bye.